LeetCode 41, first missing positive. How to solve hard LeetCode problems creatively with JavaScript. I didn't look at any of the other submissions or any of the discussion. I dove right in and got good performance. After making a few tweaks and changing the submission a couple times, I got pretty good performance out of this. And here's what I did. Let's start with a problem. Given an unsorted array of integers, nums, return the smallest missing positive integer. You must implement an algorithm that runs in O of n time and uses constant extra space. Definitely runs in O of n time. It uses extra space. I don't know if constant extra space is correct. Anyway, is that like 2n space? I'm not sure what they mean by that. So, given the examples, input nums 1, 2, 0, output is 3. Okay, so if the numbers in the range of 1 to 2 are all in the array, right? So 0 is eliminated because it's not a positive integer. 1 is a positive integer, 2 is a positive integer, and then this edge case, we have to return what would be missing would be the last thing after the array. That's an edge case. There's another edge case. Example 2. Nums equals 3, 4, negative 1, and 1. The output expected is 2. We eliminate 1. We have 1, 3, and 4. So 2 is missing. Now, example 3. 7, 8, 9, 11, and 12. Output expected is 1. So we don't start at 7 and look for 7's there, 8's there, 9's there, 10 is missing, which is what I initially assumed they wanted. That was wrong. They want the smallest missing positive integer. Smallest possible one is the possible smallest integer is 1. It's the smallest integer you can have, and it's missing here. So that's the output. Now on to my solution, my creative JavaScript solution. I basically filtered the array and sorted the array, and then looped through it, starting from the beginning of the array to the end, and looked for the smallest possible integer of all the possible integers in that array, starting from 1. So if we got 1 and that's there, then okay, we're okay until we get to something that's missing. And if we don't find something that's missing, we return the last element of the array and add 1 to it, right? So if we got 1, 2, 3, then we're going to return 4. 4 is missing. Okay. And that's what they want. The way I did it is to implement a filter function, positive unique. I filter this nums array, positive unique, by filtering all numbers that are positive and unique, because we don't want doubled numbers when we get down here to this loop. So if we have 1, 2, 2, 3, we're going to look for expected is going to be equal to I is 0 plus 1. We're expecting 1. Okay, we got that. That's fine. We get to 2. Expected would be 2 plus 1. That would be expected to be, 1 plus 1 would be 2, because I would be 1. Okay, so we're okay there. And then we get 2 again. Expected will be equal to I would be then 2. 2 plus 1 is 3. And then we would have 2. Expected would be 2, but the actual element would be 3. And then we would be returning 2. Oh, it would say 2 was missing. No. Or 3 was missing, but it's not. It's not missing. It's just, it's the next one because I have a double 2. So we have to return the smallest missing one. And 3 is not missing. It's just we have an extra 2 in there that makes it look like it's missing and could make our loop not work. So that problem right there makes us think, so we need a unique array. And we need to filter out everything that is less than 1. So let's filter out positive unique numbers. Okay, so then we filter this nums array with positive unique numbers, and then we sort it. And the way we sort it is using an unsigned 32 int 32 array. And the reason for that is this sort function is faster. And the uint32 is necessary to match the requirements of the constraints. The constraints is that nums I could be 2 to the power of 32 minus 1. So we need these big numbers in there. So we're going to have some big numbers in this array. We're going to have a lot of numbers in there. 10 to the power of 5. Lots of numbers in there. Okay. So let's use the new uint32 array. And the way this filter function works is rather interesting as well. We use what I'm going to call a poor man's set. So what I first did, and you'll see in the submissions I made a few attempts, is I filtered everything so that we have all positive integers, and then I pass that to a set. Very straightforward, and it works. But it uses a little extra memory. So how can we use less memory? Well, what I did is I created a map, and that uses less memory here. So unique E is E in unique. And let's step through this. I like to step through the problems when we have these filter functions. It's good mental exercise. So we start with this 1. If we have an array, let's say we were given an array of this, and that's what nums is. Let's say nums is equal to this array. And we pass, we start with the filter function. We go with 1. Unique 1. First we're going to say E is greater than 0. 1 is greater than 0. Yes. Unique, our object here, 1 is equal to 1 in unique. Well, 1 is not in unique, so that's going to be false. 1 in unique is false. The result of this expression, unique E equals false. Okay, so does that mean it's not there? No, it is there, and it has the value false. We negate that value. So now we say unique E is going to be true. Okay, so E is greater than 0, and that's true, and this is true. So the result of this this binary operator, this AND expression here is true, right? So that gets added. So 1 gets added. The next one we have is 2. 2 is greater than 0. Unique 2 is equal to 2 in unique. That 2 in unique is false. So now unique 2 is equal to false. Not false is true. That gets filtered. The positive, that's in. So that's in. It's not filtered out, it's filtered in. The next one we get is 2. So now we say 2 is greater than 0, true. And unique 2 equals 2 in unique. 2 in unique is true. The value of unique 2 is false currently, but it is in unique. And then we assign that to unique 2 is now true. And then we say not true. Oh, not true is false, so that's not going to get added. So this 2 would not get added to the array. And the same thing would happen with 3 that happened to the first 2 and the first element that we got, 1. And so that's how we filter out the array to have positive unique numbers without having to use an extra set. We do have to use a map, but it is much better with memory than the set. So there you have it, guys. There is my creative approach for solving a LeetCode hard problem with a creative use of JavaScript. And I did this without looking at any of the submissions, without looking at any of the solutions, without looking at any of the discussion. I just went straight to it, and you can see that I had a bunch of attempts where I optimized for my performance, and eventually I came upon one where I hit it off lucky with this particular one. This was really what did it. I tried back and forth and changing this around. This was really the most performant way to do it, and I did actually get pretty good performance. I'm still not up there as far as memory usage goes. That could be improved. So it's not the best solution for memory, but it's pretty damn good considering the constraints of this array where we have a lot of data, a lot of nums, and big numbers as well. Thanks for watching.